Okay, let's take a look at the practice test. Remember, the numbers here might be different than the numbers you have on your practice test because it gives you new numbers every time you try one, but it should be the same type of problems. So on this first one, we want 42% of 350, so 42% as a decimal is 0.42. Of means times. So 0.42 times 350, if we punch that in the calculator, this one we get 147. It says round to the nearest hundredth if necessary. It's not necessary here because we'll get a whole number. Okay. Number 2 says change the fraction to a decimal. Sorry about that arrow there. I don't know what to do to get rid of it. So what we're going to do is we're going to do 80 divided by 105. If I can get my pen to work. There we go. So 80 divided by 105. And we'll get a decimal, and then we'll change that to a percentage. So 80 divided by 105, I'm getting 0.76190447, on and on. Okay, but we want to change it to a percentage, so we would move our decimal place 2 places. And then it says round to the nearest hundredth, so we wait to the end for that. So that would be 76 point the 10th position is here. We want to round it to the 100th position. So our next digit's a 0, so we just get 76.19%. And so change it to a decimal first and then to a percentage. Okay. Number 3 says if your dinner bill was $41, you leave a 20% tip. How much will the tip be? So we want to figure out, say it in words, we want to figure out 20% of $41. So that's 0.2 times $41. Okay, so 0.2 times 41, we get $8.20 for our tip. And you can do it the mental math way. You can say, well, $4.10 would be 10%. So times 2, $8.20. That's okay. Either method's fine. Okay. Or get into some of the geometry. This one says find the circumference. Make sure you're looking to see what you're finding. Okay. It says find the circumference and use our estimate for pi of 3.14. If you use the pi key on your calculator, you're going to be a little off from what we're getting estimating. So circumference, okay, is pi d, or we also have another version of the formula that says it's 2 pi r. On this one, we're given the radius, so this is going to be r. Okay, so for our circumference, it's going to be 2 times 3.14 for pi times our radius of 34 centimeters. 2 times 3.14 times 34. We get our circumference of 213.52, and it's just regular old centimeters. Not units squared for circumference, it's just regular units. Okay. Number 5. Again, this is where you have to read the problem carefully, okay, because this one says, well, you got the same kind of figure, okay, but we've got to make sure we're reading to see what it's asking for. This is how many square centimeters of paint would be required to cover the top surface. So here we want area. Okay? And for area of a circle, it's on the formula sheet. It's pi r squared. So, oh yes, again, I will give you a formula sheet with all the formulas you need. Okay. So if we want area on this one, 3.14 for pi. Our radius halfway across is 15 centimeters. We've got to square that. So 3.14 times 15 squared gives us 706.5. And this time they are square centimeters. Here's our area. It says round to the nearest hundredth. It came out to the nearest tenth, so we don't have to round. Okay. Number 6 is an easy one as long as you realize it's a formula off the formula sheet. And the formula is n minus 2, sides minus 2, times 180 degrees for the sum of the interior angles. So here we have a 17-gon, a 17-sided polygon. So that means we're going to do 15 times 180 degrees to figure out what all the interior angles add up to. So 15 times 180 gives us 2,700 degrees. If we add up all the interior angles on a 17-sided polygon, we're going to get 2,700 degrees, or 2,700. Okay, number 7 says find the volume of the figure. So we know we got to find a formula for volume, okay? And we have to figure out what shape it is. So this one, the picture looks like a cube, but all the sides are not the same. So this one would just be a rectangular solid. So volume of a rectangular solid, length times width times height. So for our volume here, it doesn't matter which one you call L, W, and H. So we've got 10 times 4 times 7. Okay. Punch that in our calculator. I get 280, and it's volume. So our units were feet, but since it's volume, that's 3-dimensional, so feet cubed. Okay, cubic feet. For 8, it says find the volume of the figure. What kind of figure is this? This is a cylinder. Okay, so I never remember this one, so I'm going over to the formula sheet. And so we want the volume of a cylinder. It's pi r squared h. I should remember that, but I don't. So our volume for a cylinder, pi r squared h. Remember, we're using 3.14 for pi. So 3.14 times our radius squared. Our radius here is 7. It's halfway across, so 7. And then our h, our height, we're 5 centimeters tall. So this is squared times 5. 3.14 times 7 squared times 5. We get a volume of 769.3. Our units were centimeters. We're finding volume, which is a 3-dimensional measurement, so cubed. Cubic centimeters here. All right, number 9 is find the surface area. Okay, so let's look at the surface area formula. You don't necessarily have to use the formula. So just remember what we're doing. We're finding the area of each face and adding all those together. We got 6 faces. But since it's rectangular, the front and back is going to be the same. Left and right is going to be the same. Top and bottom is going to be the same. And so that's why we get the weird looking formula: 2 times width times length plus 2 times height times length plus 2 times height times width. It doesn't matter what order you do them in. Just got to make sure you get them all in there. Okay. So for our surface area here, I'm going to do the 11 and the 6 first. Plus 2 times, we'll do 11 and 7. Plus 2 times the pair we haven't used is 6 and 7. Okay. What do we get here? 2 times 11 times 6 plus 2 times 11 times 7 plus 2 times 6 times 7. We get 370. And a surface area, the area is a 2-dimensional measurement, so we get square yards, 370 square yards. Number 10, doing some unit rates. We're trying to figure out which one's the better by. So the thing to say it out in words here, we're trying to figure out how many index cards we get per dollar. So the one where we get the most index cards per dollar is going to be the better by. So per means divide, so we're going to do 200 index cards divided by $2.84. And that'll figure out our unit rate here. So 200 divided by 2.84 is going to be 70.42 index cards per dollar on the first one. we'll do the same thing. We're going to do 25 index cards per the money of 66 cents. We'll figure out our rate there. So 25 divided by 0.66 gives us 37.88 if we round. So which one's better? We get more index cards for the money with the first one, and we get 70.42 index cards per dollar that way. Okay. That is our better buy. And make sure you don't get it backward. You don't want to do dollar per index card. Okay. You want the unit price so the money goes on the bottom. And number 11 is how much soda do you get per dollar? Okay. So it says we've got 3 liters of soda per $2.85. So per means divide, so 3 divided by 2.85. Okay, so we're going to get 1.05 if we round a little bit liters per dollar. Because liters were up here and this was money. So a little bit over 1 liter per dollar. And so whatever it says per, that goes on the bottom. Number 12 says the ratio of children to adults is 5 to 8. There are 150 children at the opening of the new museum. How many adults are in attendance? So with these ratios, we've got 5 children to 8 adults. And we're trying to make that match up with if we have 150 children, how many adults are we going to have? So we're just like trying to get equivalent fractions here. So we can do 150 divided by 5 gives us 30. So if we multiply 5 by 30, we get 150. So if we do 8 times 30, we'll get 240. So all we're doing is we're saying 5 times 30 is 150. And I figured that out by dividing 150 divided by 5. So if I do 8, which is my adults on the first ratio, times 30, we figure out how many adults we'll have is 240. So 240 is our answer there. Just like fractions, you can write them as fractions if you prefer. Okay, number 13 says the blind taste test is over and a new favorite fruit juice flavor has been selected. The new flavor received 4 votes for every vote by the original flavor. The new flavor received 744 votes. How many votes did the original flavor receive? So the new got 4 votes for every 1 vote the original got. So if the new got 744 votes, how many did the original get? So it's just like the last problem. Okay, we're probably going to get a decimal here, but I'm still going to divide. I'm going to do 744 divided by 4. Okay. And we actually get 186. So 4 times 186 is 744. So then I do 1 times 186. That's an easy one. Right? Gives me 186. So how many votes did the original get? 186. Just figure out what you have to multiply by to make it match up. Okay, number 14, got a clearance sale. It says all clearance items are marked an additional 35% off their sale price. Address that it originally cost $70 before any discount is on sale for 20% off. What is the final price? Round your answer to the nearest cent. So our dress originally cost $70. It is on sale for 20% off. So let's figure out our discount. 20% is 0.2. So how much discount are we going to get from the sale? We do 70 times 0.2, and we get $14. That's our discount. So 70 is our original price minus our $14 discount. So 70 minus 14, we get $56. So this is our sale price. And then we got another discount we got to do. We got to do the clearance discount. So we got to take 35% off the sale price. And it says 35% off the sale price. So to figure that out, we got our sale price times 35% or 0.35. Okay, so how much discount are we going to get there? Let's see, that is $19.60. That's our second discount. So we do 56 minus our discount of $19.60. 56 minus 19.6. We get a final price of $36.40. And there are several other ways you could work this problem and get to the same answer. So the way you work it's not necessarily important. So you can, if you have a different method and you're more comfortable with it, that's okay. That's probably not the way I would work that if I was doing it for myself either. Number 15. We got sales tax this time instead of a sale. So our iPod cost is $136.99. We have a sale tax of 6.5%. What's our total going to be? So we need to figure out our tax. So 6.5% as a decimal. And we move 2 places. Right, so it's 0.065 times our price, 136.99. This will tell us how much our tax is going to be. 0.065 times 136.99. So our tax is $8.90 if we round. Okay. That's our tax. So then we have to take our original price plus our tax. Okay. So 136.99 plus 890. We get our final price, our total price of $145.89. That's retail price and tax together. 16, we're building a sandbox. We got the dimensions. We want to know how many cubic inches of sand the sandbox can hold. So cubic inches, and if we have cubic dimensions, it's going to be volume. It says it's rectangular, it gives you length, width, and height. So our volume here is going to be 53 times 53 times our height, which is 16. So let's see, 53 times 53 times 16 gives us 44,944. It was inches and it's volume, so cubic inches of sand. And just length times width times height there for volume. Okay, 17 looks similar, but it's a little bit different because this one tells us we want a volume and we want a sandbox that can hold 44,590 cubic inches of sand. And it gives us 2 of the dimensions. It gives us the length and the width, and it asks us how tall it needs to be or how deep it needs to be, depending on if you're putting it in the ground or not. So all we do is we take the same formula, but this time we know V. And V is 44,590. Okay. Our length is 70. Our width is 49. And our height, we don't know. That's H. Then we solve for H. So 70 times 49 is 3,430 H. And that equals 44,590. Then we divide both sides by 3430. That will leave us with H on the right. That's what we want. So 44,590 divided by 3430 and gives us 13. So that is our H. So if we want to put units on there, our sandbox needs to be 13 inches tall. Just a little bit of algebra thrown in with that one. 18, a little bit of probability. Got an experiment where we're rolling an 8-sided die and then we're flipping a coin. So for the 8-sided die, our options are 1, 2, 3, 4, 5, 6, 7, or 8. And then we either get heads or tails on the coin, identify the sample space. So we're just listing out all the possibilities here. Okay, so we can just start with, if we flip heads, what are our possibilities for the die? Okay, I guess we can do the die first. So we could do a 1 in heads, or 2 in heads, 3 in heads, 4 in heads, 5 in heads, 6 in heads, 7 in heads, 8 in heads. Or what about if we get tails? Then it's exactly the same, but we just switch it to tails. So 1 tails, 2 tails, 3 tails, 4 tails, 5 tails. I'll try to remember not to give you one this long. 6 tails, 7 tails, 8 tails. And so that would be everything that could happen, right? That's each possible die roll with each possible coin flip. And if you want to make sure you got them all, we got 8 choices for the die, 2 choices for the coin. 8 times 2 is 16. Count them, and we should have 16 there. Number 19. Find the probability of obtaining exactly 1 head when flipping 5 coins. So all right. So we want to get 1 head when we're flipping 5 coins. Okay, you could list all these out, but it's kind of long, so let's work it a little smarter on this one. So if we've got 5 coins, how many ways could we get 1 head? Well, we could get it on the first coin, or we could get it on the second coin, or we get it on the third coin, or on the fourth coin, or on the last coin. So how many ways could we get 1 head? We've got 5, right? 5 possibilities for getting 1 head. And how many total possibilities do we have? Well, we've got 2 choices. The first coin could be heads or tails, right? The second coin could be heads or tails. The third coin could be heads or tails. Fourth coin could be heads or tails. The fifth coin could be heads or tails. You could get this by listing them all out, but this one would be long that way. Okay, so there's 2 choices for what we can get on each coin. 2 times 2 times 2 times 2. What do we get there? I believe that's 32. Okay, so we've got 5 ways that we could get 1 head out of how many possibilities? 32. Okay. And fraction in the lowest terms, that's fine. You can change it to a decimal if you want to, but that's extra work. So 5 out of 32. And 20 says evaluate the factorial expression. Okay, so the main thing on this is know what factorial means. If you see the exclamation point, it means you start with that number and you're multiplying it by every other number smaller than that. So on the top here, that means 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And the big point here is that you can cancel a lot of this stuff out, because on the bottom, 8 factorial would be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That's 8 factorial. And then 4 minus 2 factorial. 4 minus 2 is 2, so that'll be 2 times 1. And then look what happens. We've got 8, 7, 6, 5, 4, 3, 2, 1. All that cancels out. Okay, so all we got to figure out on the top is we've got 11 times 10 times 9. So that's 990. Divided by, what do we got left on the bottom? Not much, 2. So 990 divided by 2, 495. Okay. So that's kind of tricky to do on a calculator, but it's not. It's actually pretty easy if you just cancel all that stuff out. You just got to remember what factorial means. Start with that number and you multiply it by every number smaller than it till you get down to 1. Okay. Number 21 says a mother duck lines her 7 ducklings up behind her. How many ways can the ducklings line up? So you have to think, does the order matter? Yeah, the order matters, because if duck A is in the front, that's different than duck B being in the front. Right? So we got 7 ducks. So for the first duck, we got 7 ducklings we're going to line up. For the first duck, how many choices do you have for which one goes in the first spot? You got 7. But then we've already picked one. So how many choices do we have for the next spot? Only 6. Then we've used 2, so for the next spot we've only got 5 choices. Then we've used 3, so we've only got 4 choices. And then 3 choices, then 2 choices, and for the last duck, by the time we get there, we've used everybody else up, so we've only got 1 choice. We only got 1 choice. So what is this? This is the same thing as 7 factorial. So let's do it. 7 times 6 times 5 times 4 times 3 times 2 times 1. How many different ways can she line her babies up? 5,040. And that always blows my mind, right? You only have 7 things. How many different ways can you arrange them? It's over 5,000 for just 7 things. That's pretty amazing. Okay. All right, so I think that's it. If you have any questions, let me know. Sorry, I freaked the screen out there. There we go. If you have any questions, let me know.